Welcome this evening, everyone, to our May general meeting of the Kalamazoo Area Wild Ones. I'm Noelle Osen, President of Wild Ones, and it's great to see all of you this evening. Before we begin our program, I'd just like to give a big thank you to everyone who supported our annual plant sale. We sold almost 2,000 plants, and the sale was a great success, thanks to all of you. Our program this evening is entitled Neonics, the Toxic Truth, the Pesticides Threatening Bees, Birds, and Our Health. Our presenters this evening are Dan Raichel, Director of Pollinators and Pesticides for the Natural Resources Defense Council, and Lena Freij, the Attorney for Pollinators and Pesticides, also with Natural Resources Defense Council. Dan and Lena will take questions at the end of the program for as long as time permits. You can enter your questions into the Q&A anytime during the program. The chat will not be functional this evening. Now I'll turn the program over to Dan and Lena.
Well, thanks, Noelle, and thanks everybody for having us here tonight. I'm going to attempt to share my screen here. Okay. And I'm going to escape. Oh. Let me get back there. All right. Okay. Let me go back to the beginning. Okay. I think that did it. Can everybody see that?
Yes, you're good.
Okay. Well, again, thanks everybody for having us today. We wanted to talk a little bit about neonicotinoid pesticides, or neonics for short, and in a nutshell, why we think these may be some of the most ecologically destructive pesticides that we've seen since DDT. To kick things off, we'll start with the humble honeybee. And I'm sorry, there might be a slight delay here in terms of the images, so I'll apologize for that in advance. I think we just had World Bee Day yesterday. I think most folks on this call probably are aware bees are incredibly important. Bees and other pollinators provide about 1 out of every 3 bites of food that we eat. And to give you a sense of what that looks like in practice, here's a grocery store in the world that we live in with bees and other pollinators. Here's what that same grocery store looked like in a world where we lose our pollinators. Certainly we would still have food. We would just lose a lot of our choices. A lot of the most delicious and nutritious items would disappear. We would have a lot less food, and it would all be a whole lot more expensive. So outside of the grocery store aisle, we know that bees are incredibly important to ecosystems. So bees and other pollinators are support 80% of the plants on the face of the earth. 80% of the plants on the face of the earth require some form of pollinator to reproduce. So if we lose our bees and other pollinators, we're concerned not only about food insecurity and food prices, but also the collapse of ecosystems. These are really keystone species. So, sorry, I think that's a random slide. We are sort of concerned about that, right? Because about 20 years ago, beekeepers in Michigan and across the country started to lose their colonies of honeybees. Up until that point, beekeepers were losing maybe 10–15% of their colonies every year. And those numbers jumped to 30, 40, 50% virtually overnight. Those loss trends have continued to the present day, right? So we've lived with them for a little while now. They've become sort of the new and scary normal. But as you can see in recent years, the loss trends have gotten even worse. From 2023 to 2024, beekeepers reported losing 55% of their colonies across the country. Those are huge, huge numbers. And you'll see too that in a lot of these years, we're seeing summer losses sometimes higher than the winter losses. So we know something new is happening here, well, new for the last 20 years, as opposed to when beekeepers were traditionally losing their bees. Last year, from what we've heard, we don't have the numbers yet, that the losses were even worse, that we saw loss rates maybe 60 to 70% of hives. Now, the good news is that honeybees are livestock. They're actually not native to the United States, and we have beekeepers. So when beekeepers lose bee colonies, there is a whole industry that is breeding new colonies, new queens, and we're replacing hives at about the rate that we're losing them. Now, at some point, that may become unsustainable, may become economically unsustainable, but we're maintaining our levels of honeybees, even if they're maybe weaker than ever and sort of being held, that whole system being held together with duct tape. The same is not true of our thousands of species of wild bees, and there's over 400 in Michigan alone, 4,000 in North America. And those wild bees, from what we know, what we're seeing with honeybees, because we count honeybees, but we don't really count all of our wild bee species. What we're seeing with honeybees is indicating us they're sort of the canary in the coal mine, right? What's happening to honeybees, maybe not to all wild bees, but to a number of them, the same thing is occurring, and it's occurring across our ecosystem. And we're already seeing that in a number of crops being pollinator limited. In Michigan, this is particularly poignant, and actually a lot from this study that's shown here, a lot of the data is coming from Michigan. We're seeing crops like apples, blueberries, and cherries being pollinator limited, meaning farmers are growing fewer of those crops already because we don't have more pollinators. And a lot of that is, the honeybees are getting weaker, but it's also the wild bees that we're losing. And recent studies are showing for any given crop, it's usually about 50-50, right, in terms of honeybee pollination and wild bee pollination, and we're losing those wild bees. So there's a lot of problems that are affecting bees. Why are we talking about pesticides and why neonics in particular? We know that climate change is a problem. It's a growing problem for pollinators. We know that habitat loss, parasites, pathogens, these are all problems that bees face. Why do we care so much about neonics? I think it's first helpful to know exactly what are neonics, right? So neonics are neurotoxic insecticides, which means they are pesticides designed to kill insects by attacking their nerves. And the way that they do that is they mimic nicotine. The name neonicotinoid actually means new nicotine-like substance. And they attach to insect nerves at the sites that would respond to nicotine. But unlike nicotine, they attach to those sites permanently, and they don't let go. And they stimulate those nerves. They continue to stimulate and stimulate and stimulate them until the nerve eventually dies or fails. And so if you've seen a bee that has been acutely poisoned with neonics, oftentimes that bee will start to twitch uncontrollably before keeling over and dying, which is a little bit gruesome, but all pesticides to some extent are gruesome. Why do we care so much about neonics? And there are three big reasons. The first is that neonics are super duper toxic to bees and other insects. And to give you a sense of scale here, the thin coating on one corn seed, neonic coated corn seed, and I'll explain what that is in a second, has enough active ingredient to kill about a 250,000 bees. 1 square foot of treated lawn, by the way, at the EPA approved rates, has enough active ingredient to kill about 1 million bees. So in fact, we've seen since neonics introduction that they have made U.S. agriculture about 48 times more harmful to insect life. And where we see that harmfulness spike is almost exactly at the point that we see that sudden uptick in losses of honeybees. And all these other factors, climate change, habitat loss, parasites, pathogens, all problems for bees. But we didn't have a sudden increase in any of those stressors the same way we had the sudden increase in use of neonics at exactly that point where we saw the losses of bees. And this is in particular where they started to be used as coatings on crop seeds. And again, I'll talk about that right now. Second problem with neonics is that they're very good at contaminating whole ecosystems. So they're designed to permeate plants, to get into the leaves, the roots, the pollen, the nectar, the fruit, everything. Basically to make the plant itself toxic, to make the plant itself pesticidal. And that means that neonics can be applied in all sorts of new and interesting ways. They can be sprayed, and they are for sure, but more commonly, they're applied to soil, or they're literally painted on crop seeds. And here's a picture of what that looks like. You have some neon-coated corn seed. And here's a close-up, just so you can get a better look. It's not the same seed, and they don't always pick the same color. And apologies if there's a delay there, but this is some neonic-coated corn seed. And the idea is, as that seed is growing into a plant, it literally soaks up the pesticide coating through its roots and becomes toxic, every part of it. And the issue with that is only 2 to 5% of the active ingredient actually gets into the target plant. The other 95+% stays in the soil where it persists for years and years and years. I should note too that the pesticide coating is sort of coated on there with microplastics, but that's another issue. So that pesticide stays in the soil there for years, and the same properties that let the pesticide get up into the target plant means that they're really mobile in the environment. So anytime it rains, anytime there's irrigation, lawn watering, those neonics are moving through the soil. They're contaminating new soil. If there's plants in that soil, they soak up the pesticides, they become toxic, their pollen, their nectar. If there's a water supply nearby, that water supply becomes polluted. The third problem with neonics is that they are just all over the place. So just about 100% of conventional corn is pre-treated with the neonic, 50 to 75% of soybeans, but they're also all over lawns, gardens, golf courses, other agriculture, bed bug products, pet products, you name it. These insecticides are the most used insecticides in the US, and they are everywhere. And to give you a sense of scale there, again, one neonic treated corn seed has enough active ingredient to kill 250,000 bees. Multiply that times 30,000 seeds per typical acre of corn. Multiply that by 90 to 100 million acres nationwide, about, I think, a little over 2 million acres in Michigan. So you can start to get to see what the nature of the problem is. Here's another way to visualize it. This is the use of just one of the neonic chemicals, not even the most used in agriculture. And what I'll say is there's 5 neonic chemicals, 3 big ones. This is one of the 3 big ones. Again, not one of the most used in agriculture. And this is just agricultural use. So areas around Detroit, around Kalamazoo would be filled in, those white areas, if we were looking at those lawn and garden uses. But what this does give you a sense of is that even with just this one chemical, right, and just the ag uses, you can tell that these pesticides are being used on a massive, massive scale across the country and across Michigan. And what's happening is they're being used in the same places year after year after year. So what you start to get is a buildup of toxicity in the soil that's constantly expanding every time it rains to get into every nook and cranny of the ecosystem. Soil, water, plant life, wildlife, etc., even our own bodies. So that's the nature of the pollution problem. And we see that in Michigan, right? So we see, where you see it is in the water testing. USGS did some good testing in 2018. They're finding these pesticides showing up year round in tributaries to the Great Lakes. Other testing and state and federal testing is showing neonics pretty frequently in surface waters. So we're seeing them maybe a little less than half the time, although that's quite a lot, right? And almost all of those are above EPA benchmarks for harms to aquatic ecosystems. And what's that's indicating is, and usually you'll see them, especially after a rainfall, that there is a significant amount of these pesticides in Michigan's environment, and that is pretty consistent across the board. Michigan is not unique in that respect. So what impact is all of this having? Well, one, neonics are definitely driving losses of bees. This is a study of honeybees. This is actually a study funded by industry itself at the time, and I think this is still true. It was the largest field study ever conducted. It cost millions of dollars. And lo and behold, it found that neonic-treated seeds are driving losses of honeybees. We're also seeing neonic impacts on wild bees. This is a great new study that came out last summer, linking neonic use to the losses of wild bees across the country. Hugely important study, really important science, sort of, not surprising, right? But good confirmation. Another big study that came out last summer was one looking at Midwestern butterflies. This was actually conducted with MSU professors. And what the study found was that neonics were the #1 factor in the declines of Midwestern butterflies, more so than climate change, land use change, more so than other pesticides, and in particular, the use of neonic-treated seeds. And that was true, also for the monarch butterfly, probably the most famous butterfly. #1 factor associated with monarch declines in the study period was the use of these neonic-treated seeds. Look, not everybody cares about bees and butterflies, but we know that what's happening to bees and butterflies is indicative of what's happening in ecosystems. And we know that we're losing insect life at a massive rate, and it's sometimes been called, an insect apocalypse. And the analogy here is for folks who can remember driving around a rural area in, say, the 1990s, you'd have to turn on your windshield wipers, whether, if you're driving around in August, turn on your windshield wipers, whether it is raining or not, just to get all the bugs off of your windshield. And think about, when was the last time you really had to do that, or that it was as bad as you remember it being? I mean, I have memories like, the whole windshield. And that's sort of the visible element of this. We've lost just a lot of our insects, and a lot of people say, well, they're just bugs. It doesn't really matter all that much. I don't like bugs anyway. But certainly other species notice, and if you're a bird, you're not very happy about the loss of insects. So we see, most birds rely on insects as a critical source of food. So we see, unsurprisingly, studies linking neonics to losses of birds and bird biodiversity, particularly insect-eating birds. I think folks may have seen the study that came out of Cornell a few years ago. 30% of our birds lost, 3 billion birds in the last 50 years. Interestingly enough, a couple of other authors went into the data set of that study after it was done, and they teased apart the bird data in sort of two groups: the birds for which insects were not essential, and those for which insects were essential. The good news is, for birds that don't rely on insects, the last 50 years have not been that bad. Actually, in some cases, they've gained population. But the bad news is if you're a bird that relies on insects, you've been getting hammered. And also that most birds, the vast majority of birds, rely on insects. Same things happen in aquatic ecosystems. This is a study out of Japan. The study authors were looking at zooplankton. Here's a picture for folks who don't know of zooplankton. They're sort of water bugs. And what the study authors found was in the early 90s, the zooplankton populations they were studying just hit a wall. And at the same time, in this otherwise sustainable fishery, the catches of fish that relied on the zooplankton as a source of food also dramatically crashed. And nobody knew what was going on at the time. They later connected it to the introduction of neonics and nearby agriculture. This is actually one of the first places neonics were introduced in the world. They were approved in Japan before the United States. And it's a really unique study because we just don't have data for all of these other ecosystems, right? We don't have the before and after. We don't have the before. But what we do have is water testing that shows that the neonic levels they were seeing in Japan match those that we see all across Michigan and all across the United States. And not super high levels either, right? Parts per trillion, but these pesticides, again, are so phenomenally harmful that they are harmful at those levels. Unsurprisingly, or maybe a bit surprisingly, EPA announced a couple of years ago that neonics are likely driving 200 endangered species towards extinction. I cannot tell you what a wacky large finding that is. It is against the Endangered Species Act to even drive one species towards extinction. This is 200 plus. I've never seen a determination this large, like not even close. So it's not the final say in the matter. Fish and Wildlife will have to do a determination with things going on these days. We don't know what's going to happen with this process. It does again just speak to the nature of the harm here and these species being sort of canaries in the coal mine. And I think with this, Lena, I'm going to turn it over to you.
Thanks, Dan. Yeah, so in addition to the indirect effects that Dan was talking about, it's really important to highlight that neonics also directly are toxic to things with spines. So they don't harm just insects. Just one neonic treated seed has enough active ingredient to kill a small songbird if that seed is ingested. And if you're curious, or maybe you're unfamiliar with bird diets, and you're curious if birds eat agricultural seeds, they absolutely do. There is admittedly not a ton of research on this, but there was a very good study that was done out of Minnesota that found that it was pretty common to find that birds eat seed spillage. So especially during planting season, for these really major crops like corn and soybean. And things start to get really scary when we think about mammals. So several years ago, hunters in the Midwest started noticing these really strange things going on with the deer that they were hunting. It's really surprising and just unusual deformities that you really do not encounter in nature normally. And one of the thoughts was that maybe some of these deformities may be connected to neonic use in nearby agriculture. And so some researchers did some controlled studies where they exposed deer to real world levels of neonics in their water. So this included deer that are still in the womb, so deer exposed to neonics in the womb. And what they found was that these exposures were related to deer being born with deformed jaws, unnatural and strange organ sizes, increased rate of stillbirth and fawn mortality. And even for adult deer, there were a whole host of brain and hormonal issues arising. Now, of course, industry's response to this was, well, that's not a real world experience for deer. It's a controlled study. This doesn't reflect what deer are actually exposed to in nature. And so the Minnesota government just responded by, asking hunters across the state to submit spleens of the deer that they've caught. So, as you can imagine, there were 800 deer spleens just casually making their way through the mail. And they found in looking at these spleens, not only that neonics are in deer, but that they're increasing by over 30%. So between 2019 and 2021, Neonics went from being in 61% of deer to 94% of deer in Minnesota. And it jumped from having 29 to 64% of those deer above levels associated with higher rates of birth defect and death from that previous controlled study that I mentioned. And these are results statewide, right? Like they got deer from across the state. And that's a pretty big concern because deer are huge mammals and we are also pretty big mammals. So using 2016 data, CDC research found that about half of the United States population is regularly exposed to neonics. And they know that through a biomonitoring study. So they actually found neonics in people's urine or the breakdown of those pesticides in people's urine. And a more recent study found neonics in over 95% of 171 pregnant women, with the highest levels in Hispanic women. What was really scary about that study was that each year of the study, the levels increased. So over those 4 years, pregnant women were getting more and more exposed as the years progressed. And those exposure levels are a big concern because studies are also suggesting that neonics may increase the risk of developmental and neurological damage in humans. Even though, if I'm just being transparent with you, I think a lot of that research is still in its infancy now. I think we're just going to see more and more coming out in the coming years. But even just using population studies, because we know the controlled studies are unethical for humans, but using those population studies, we're seeing that neonic exposure is associated with birth defects in the heart and brain, with autism-like symptoms, decreased sperm count and testosterone. It's pretty consistent with these controlled animal testing studies that we've been seeing. And as far as human exposures go, right, like where do we ultimately get exposed to neonics? Most of it comes from drinking water. And we think that because drinking water supplies are pretty regularly and fairly frequently contaminated with neonics. And on top of that, most conventional water filtration systems do not actually filter out neonics, unfortunately. And in addition to water, we understandably and maybe expectedly also get exposed through our food. And that's kind of by design, right? If we think about what Dan was talking about, the way that neonics work in their systemic nature is that they permeate plant tissues. That includes fruits and vegetables. So when you have produce that has been treated with neonics, you unfortunately cannot wash it off. The pesticide is literally infused in the produce. You're going to eat that contamination. And of course, that raises equity concerns, right? Not everybody has equal opportunity to avoid neonic exposures. In addition to the direct disproportionate effects that we see that neonics have on Hispanic pregnant women that I mentioned earlier, we also see that there are really clear inequities in the way that neonics indirectly harm low-income, food-challenged communities because, eating organic is a great way to reduce consumption of pesticides, but of course it's generally more expensive. It's oftentimes inaccessible in low-income communities. And, water filtration systems are also expensive. So with rising food costs, due to loss of pollinators, we can just expect to see nutritious food become more expensive and likely just hitting these low-income communities of color the hardest. So how is the world responding? The EU banned all outdoor uses of neonics, so that's most of the neonic uses in Europe. Those have been banned since 2018. And Canada imposed pretty significant restrictions. They initially were maybe going to go for a nationwide ban, but they changed course. But Ontario and Quebec have instituted what's called a verification of need system or program. And basically what it says is that if farmers want to use a neonic coating on a crop seed, they have to get a prescription from their agronomist saying that the seed is going to be used to address a demonstrated pest problem. So you kind of see it as like a prescription, right? You want to use it, that's fine, just prove that you need it. And so in Quebec, since its implementation, neonic use has dropped to virtually nothing. So it went from being used on 100% of corn and about 50% of soybean seeds to nearly zero. And the reason for this is that they're just not needed, right? The vast majority of neonic seed treatment use actually provides no economic benefit to farmers on average. And even when there are benefits, right, these kind of outlier situations, there's still input costs for farmers. Farmers still have to pay for that coating. So economically speaking, it's really just a wash. So we actually have people take a hard look at whether these chemicals are actually needed. It really resulted in the realization that they're just not necessary. And since then, we haven't seen any switch to harmful alternatives as a result, and Quebec is actually going to be expanding its program to include all insecticides this summer, so not just focusing on neonics. So looking at us, looking at the United States at the federal level, sure everybody knows there's just a lot going on, various statutes and processes, which I really don't need to get into all of the statutes, but I think the main takeaway at the federal level is just that there's a lot of uncertainty right now. There's a change of administration. We're not really sure what impact that's going to have. There's also staffing shortages with the recent layoffs, and we're not really clear on whether that's going to affect timelines. We haven't heard anything yet personally, but it's certainly possible that some of these processes could be slowed or delayed. Now, at the state level, there's been quite a bit of movement. Some other states, about a dozen or so, have made neonics what's called restricted use, which basically means that they're not going to be sold at Home Depot or Lowe's, just these common shelves. You're not really going to find them there. But they can still be used by lawn care companies and certified applicators. It's a great first step. This doesn't, of course, address the biggest use, which is, seed treatments, but this is a nice first step. New Jersey was one of the first states to completely ban neonic lawn and garden uses, and Maine and Nevada also passed similar laws. And New York and Vermont have actually taken pretty big steps to reduce the use of neonic seed treatment, which we know, of course, is the vast majority of neonic use. And New York was the first state to restrict it, and then Vermont followed suit shortly thereafter. So to kind of jump into the New York bill. So this bill passed just a little over a year ago, the end of 2023, the Birds and the Bees Protection Act. It's based on this Cornell report that reviewed over 1,000 peer-reviewed studies, and it found two pretty big takeaways. First, that neonic coatings on corn, soybean, and wheat seeds provide no economic benefit to farmers on average. And then secondly, what they found was that lawn and garden uses were likewise unnecessary, but also that there were a lot of safer alternatives. So the New York bill kind of ran with that. They focused on these really unnecessary uses, which are estimated to be about 80 to 90% of the use. And they adopted a very similar program to what I discussed is going on in Canada, this verification of need model, where if a farmer wants to use a treated seed, they just need to get a prescription from their agronomist. And those restrictions go into place in 2029 with a few exceptions for invasive species. There's also restrictions on lawn and garden uses as well, and those are going to go into effect in 2027. And it's estimated that this is going to reduce, it's going to reduce use by nearly 80 to 90% when fully implemented. And we're estimating that just because it's pretty similar to Quebec's experience. There, as I mentioned, neonic seed use has dropped to virtually zero. It's less than 0.5% of corn and 0% of soybeans is how much it's been reduced, to be exact. Surface water contamination has decreased significantly, and there's been really no related changes for crop yields or crop failures that's been documented based on these restrictions. And that's confirmed by monitoring at over 1,000 sites. And even preliminary findings in New York show that neonics are just about as useless as they are in Canada, so we're really expecting to see similar results there. So back to what other states are doing. I think it's the next slide after that. There we go. So what other states are doing, California is now coming up with a regulatory framework for controlling the use of pesticide-treated seeds without getting too much into the weeds, no pun intended, although pesticides different. But, pesticide-treated seeds they're not regulated as pesticides, and the reason for this is just because of some legal loopholes that exist at the state and federal level. So California is addressing that. They're looking at that loophole. They're looking at that gap in regulation. And lastly, Minnesota is also taking action. They passed a prohibition on neonics in public lands, and we currently have a petition there as well. So now for the fun part, what can you do to get involved? So first and foremost, just grow the movement. We really enjoy connecting with folks and giving this presentation. If you know other groups, organizations, even businesses that maybe we can engage with, please reach out to me. I can drop my email in the chat. We really like connecting with folks. So if anyone comes to mind, please let us know. You can also sign our letter to MDARD, which is the ag agency in Michigan. We currently have a letter circulating that is telling the agency to take action to stop widespread neonic pollution. We're targeting businesses and organizations. So if any of you are authorized to sign on behalf of them and you're interested, please consider signing the letter. I'll also drop that in the chat. It'd be great to have your name on there. You can also attend local coffee hours and speak directly to your representatives. They really, really care. It really matters. If you show up at their office and you talk about neonics, you say you care about this, they will listen to you, and that really does matter and make a difference. Likewise, you can email and call your representatives if showing up in their coffee hours is a little bit too much. If you can choose between the two, I highly recommend you call them. I think that makes much more of an impact to just have a conversation, let them know that you care about, wanting them to take action about neonic pollution. You can also stay in touch. For those who want to stay in touch, again, I'll drop my email, but there's also a Google form that we can give you to stay connected on this issue. And if you're wondering what you can do on an individual level, your choices, you can plant native plants and, of course, not use pesticides. I know that sounds like a no-brainer, but you'd actually be surprised at the places that neonics can show up. You should check your pet products. Those flea and tick treatments oftentimes have neonics. Your bed bug products, I hope you don't have that issue, but if you do, sometimes those have neonics. So keep an eye out for those kind of sneaky ways that neonics might show up in your house. So after that, I think we can hand it over to the Q&A, which I know, yeah, there's nothing in the chat, but yeah, we can discuss the Q&A now.
If anyone does have a question, you can enter it into the Q&A box, which you'll see at the bottom of your screen there. You can just click on that and type a question. And I guess while we're waiting for folks to chime in, I have a question about invasive species. I noticed that invasive species were kind of an exception in some of the legislation that you mentioned. And what do you think that neonics, their use is justified to control invasive species?
I mean, it's a tough question. So invasive species are really destructive to ecosystems. And I think, we're all familiar with species like emerald ash borer, hemlock woolly adelgid is now starting to spread across the country. Spotted lanternfly. A lot of these species are wood boring, and the way that neonics work are particularly effective at getting at some of these species, right? Like these systemic insecticides that really pervade trees. These are really tricky species to deal with otherwise. And so it's a balance. I wouldn't say that invasive species treatment in woody plants is completely without its own problems. If that tree is a blooming tree, it's going to have toxic blooms, right, that attract pollinators. But it is a cost and benefit analysis. And, some of these treatments are the only treatments that right now that we have to deal with some of these species. So it's a trade-off that, in our advocacy in other states, we've worked with groups that, address invasive species and have tried to make the carve out as narrow as possible to just get at those species. And again, it's not all invasives, right? It's really the ones that we see in woody plants. And that's what you see in New York and other places. So, we talked with a bunch of different folks, and that's sort of where we landed. But hopefully in the future, there will be treatments that don't use neonics and can address these species, and we can ultimately phase them out in those uses as well.
Thanks. Okay, it looks like we have some questions in the Q&A box now. Christina Wirtz asks, who produces neonic products, i.e. who gets rich off of their pervasive use?
Lena, do you want to take this one?
Yeah, I can take this. It's probably who you're anticipating. I know Bayer is a big producer, which, as we know, acquired or purchased Monsanto. What was that, in 2018? So it's kind of like your big name chemical producers, but I think is Bayer the primary producer? I think they are the big ones.
I think they're still the top producer. So there's, 5 neonic active ingredients, and Bayer had, I think, the first one. But now all of the neonic chemicals are off patent. So there's a number of different folks that produce these chemicals. I think Bayer is still the biggest producer, but there's a lot of folks making neonics out there these days.
Thanks. Kim Chapman asks, in what year did the curve on honeybee loss start its upward climb in the US and Michigan?
But that would be right around 2006, 2007, 2008 is when we saw that jump And that's when, if folks remember, there was a lot of pickup in the press at the time about colony collapse disorder. And we haven't seen that particular disorder I mean, you still see it. It's not quite as pronounced, I think, as it was at the time. But what you saw in that case were sort of bees abandoning the queen, a lot of like disorientation in the colonies, and folks were not quite sure what was going on. And neonics, again, fits into those explanations, because most of the time with neonics, you don't have bees just instantly dropping dead when they're exposed. What you have is this low level of exposure that's everywhere. And because it's nerve damage, it builds up over time. Because when you destroy a nerve, that nerve is gone, it's not coming back. And so you see these diseases that are more chronic and involve like neurological issues with the bees, and also that weaken bees, right? So we see higher rates. A lot of times you'll have these losses and it's like, oh, it's because of this mite, right? Or, oh, it's because of this particular disease. But we have good studies out there showing that bees exposed to neonics are more susceptible to mites, are much more susceptible to disease, which is not crazy, right? If you drink some poison, you might get sick. So, and again, that's what we're seeing. And none of those other diseases or parasites, again, they were all around before. It's not like they suddenly got worse. There's this additional factor there, and that kicked in around that time.
Thanks. Another question from Kim. Has there been congressional hearings on this issue? And if so, what has been Congress's actions?
That's a good question. They may have had some hearings back in the mid-2000s. That was before my time working on this issue. None that I know of recently. And what I would say is we're living in an interesting time. And actually I don't know if folks heard, I believe there's going to be a report out tomorrow on sort of the Make America Healthy Again initiative. And so I think there is a lot of interest in pesticides. Whether that makes it into the report or not, I know is a matter of debate. But I think there's a lot of interest in pesticides, but I don't think we're not anticipating a lot of action. So even in different times, pesticides are not something that Congress likes to act on. And EPA's pesticide office has consistently been sort of asleep at the wheel when it comes, regardless of the administration, right? Things have been, pretty much business as usual and sort of behind other countries, right? When it comes to pesticide regulation, there are a lot of pesticides approved in the US that are prohibited in Europe, in Canada, even China. So we have a very permissive pesticide office. We'll see if that changes, but I would not hold your breath.
Thanks, and that you've anticipated to some extent Ann Fraser's question here. How do regulations on the use of neonics in the US compare to those in Europe? Are restrictions much more stringent in Europe? And if so, are insect declines less severe in Europe?
I can start that one just to piggyback off of what Dan was saying. I mean, yeah, the US is very, very behind on pesticide reform. So the EU has banned all outdoor uses of neonics as of 2018. So you are not going to see neonics very often because that's the greatest use of neonics are those outdoor uses. So most uses are completely banned in the EU. The US, for the most part, you can find neonics everywhere as of right now. And there's also, I kind of alluded to this briefly, but there's a loophole that also does not treat neonic treated seeds as pesticides themselves. So you can even imagine those are even less regulated than normal neonics, which is just yeah, it's crazy to think about what that means on a scale of the whole country. Now, as for what that looks like then for, insect declines or insect populations in Europe, I know colony collapse disorder was something that was experienced in Europe, but I don't think it has been experienced to the same extent that it has been in the US. I think it's a really completely different thing. Dan, I'm not sure if you're more familiar with like the uptick maybe in that, but yeah, my guess is it's a very different story.
Well, one thing to note is that we are still seeing neonics appear in Europe, sort of legacy neonic use. And so they're actually proving to be a little bit more persistent, maybe even than suspected initially. The other thing to note is that in Europe, they do occasionally give these they call them emergency derogations, where they allow use of neonics on a particular crop. It's much more limited than in the United States, but I think particularly on sugar beets, they're allowing, there's been a number of sort of those exceptions to use neonics. There are still pesticides in Europe too that harm bees and other pollinators. And I actually read a study on that recently that, those are of concern too. But what we've heard sort of anecdotally, and I'm still looking for studies where we can really do sort of an apples to apples comparison. But when you talk to beekeepers that have been in Europe or other folks, they talk about, you see a lot more bugs in the field in Europe than you do. You see a lot more buzzing, a lot more noise than you do in, certain areas of the country, certainly in sort of more conventional agriculture in the US. So that's anecdotal. I actually we were talking with somebody recently who had some more information on that. And so we wanted to follow up with them. But again, that's what we hear sort of through the grapevine.
Thanks. This is from Christina Wirtz again. How long do these chemicals persist in the environment before breaking down, assuming that they do break down? Do they persist longer in water? Do they bioaccumulate in living tissue?
So, well, and Lena, hop in here if you have anything to add. But I think the answer is it's complicated. So there are 5 neonic chemicals. They all have different half-lives in the environment, and it depends where you find them. So they do, if they're exposed to sunlight and they're out in the open, they do break down much more quickly. But most of the time, these pesticides are sort of in the soil, and that's where that's where the battery of the pesticides are, and they're relatively persistent in soils. So for I forget what the exact half-lives are, but sometimes over 1,000 days, which means it takes 3 years approximately to get to half the concentration of neonics, and then another 3 years to get to half of that concentration. And what's interesting about the neonics is some of the neonics, when they degrade, they turn into other neonics. So thiamethoxam turns into clothianidin when it degrades. So you have to add the half-life of thiamethoxam to the half-life of clothianidin. So that's probably a little too in the weeds. I think the short answer is it's going to take a little while for neonics to get to sort of cycle out of the ecosystem. But they're not forever chemicals, at least from what we know. I did talk with a soil scientist once that says, well, we know neonic products break down, but we don't know if all of the breakdown products break down. And some of those breakdown products can be more toxic than neonics, certainly to people. So it gets awful complicated, but at least now the belief is that neonics do break down, and they don't, from what we know, they don't bioaccumulate in the same way that, up food chains, the same way that, say, DDT did and sort of stored in the fat of animals. So that is good news, although they can make their way up food chains. It's not sort of the same biomagnification, bioaccumulation, but they do pass up food chains. So, right, small bugs getting eaten by bigger bugs getting eaten by animals.
I can also jump in and add the spooky thing about knowing that they persist in the soil for so long is, as you can imagine, if pesticides were used, if neonics were used this year, and maybe they don't want to use neonics again next year, you're probably still using neonics, even though you didn't even know that, because it's probably still in the ground. So that's what's really spooky when I think about what's actually in my food is, God, how many years of chemicals have just been building and building in this soil. And yeah, it's kind of gross to think about.
A question from Kim Chapman. When do you think neonics will be banned for outdoor use in the USA as in Europe? And what do you think might tip the scale towards a ban?
Well, in terms of what we have been pushing for, it hasn't been an across the board ban. And Beth, you brought up the point about invasive species. What is problematic about the neonics, because at some level, all pesticides are harmful, right? If you think about it, they are the only chemical that we make outside of maybe the defense industry for the purpose of harming something, right? We make a lot of toxic chemicals, but they're sort of incidentally toxic, right? Pesticides are intentionally toxic. So the question with the neonics is, if you get rid of neonics, what replaces it? Or do you replace it at all? And that's a very important question because there are other nasty pesticides out there. I think the good news or the tragic news with neonics is 90+% of the use is not doing any good. What we know is the vast majority of use is on these corn and soybean seeds and other field crop seeds. And as Lena mentioned, the economics are not there, right? Very, very rarely are you seeing any yield benefit. But even when you do, the additional cost of having that pesticide on the seed, because remember, they charge for that. It's like getting the hot wax at the car wash, right? That cost versus the benefit economically is a wash on average. So in the lawn and garden uses too, oftentimes they're being used prophylactically, right? You put it on your lawn at the beginning of the season before you even know whether you have bugs or not. And it's sort of like taking an antibiotic now, just in case you might get sick in December. So that's the use that we want to stop, this widespread, indiscriminate, prophylactic, and mostly needless use. And if we get that, we get about 90% of the problem. And who knows, after that, maybe you need to do something about the 10% if it is still causing major ecological problems. But we think, let's start with that. And how long that's going to take? Well, hopefully sooner rather than later. Certainly we're trying to, I think there is a movement now and you're starting to see it, across the country and independent folks working in different places doing things. I know there's a coalition in Wisconsin doing work now, Connecticut, Minnesota. So hopefully sooner rather than later, but I won't speculate on that.
I see one more question here from Gerald Purdy. RFK caused a stir with a theory about environmental sources for autism. Could neonics possibly be involved?
Yeah, so when we talk about autism, this is very sensitive territory, and we have to be very careful about what we say and what we don't say and what we attribute to certain things. What we can say is, and we worked with, when we were working on a bill in New Jersey on lawn and garden use ban, we worked with the Autism Science Foundation, and they testified at one of the hearings. And what we can say is from these population studies, and as Lena mentioned, it's not like you can't do controlled studies on people right? Can't feed people pesticides and see what happens. But what we do see in the population studies is that there is an association with neonic exposures and autism-like symptoms. And whether you're talking about autism or whether you're talking about other cognitive impacts, I mean, these pesticides are neurotoxic. And the concern is because they are designed to attack nerves that we have in our bodies, right? It's not just insects. We, because of evolution, the basic machinery is kind of all the same. And even though the nerve sites that respond to neonics are more distributed in insect bodies, we have them in very sensitive areas of our brain and central nervous system. And it's less of a concern, frankly, for adults, but for neurological development of children, it is such a phenomenally sensitive process that if you have a chemical that is designed to attack those nerve sites, that can be a big problem. And our staff toxicologist, I mean, you can see that sort of in the animal studies. In the rodent studies, you see actually rats exposed in the womb have smaller brains, right? And so like our staff toxicologist likes to say, oh, well, you can't ask a rat how it did on its second grade math test. But here we have examples of like brain thinning from exposure to these pesticides. And Lena didn't go into the weeds of this and spared you all this, but we have a petition in front of EPA about that. We think the agency has basically been cooking the math to make these pesticides in a way that they should be restricting them more to protect human health, but they're sort of slipping out of that. So again, they're definitely neurotoxic. They definitely respond to nerves in mammals. We see these associations with cognitive impairment and autism-like symptoms in the population studies. So what you start to have is like all the little, the little pieces of evidence. I don't think we can say that neonics for sure cause autism or even contribute to autism, because I'm sure there's many different causes. But it's a needless neurotoxin in our environment, and we should do something about it.
Thank you. I don't see any more questions in the Q&A.
I have a question and I can't get through to whatever. How are they doing it with growers, the people who sell flowers and stuff? Are they still doing it? Putting in using neonics?
Yeah, definitely. So that is, it's less of a concern than you applying the neonic yourself on your own property, because those are going to be much higher concentrations. And that's part of the 10% that I think we haven't, that you haven't seen a lot of state laws go after. The nursery industry is sort of unique in that, you can have some plant damage in agriculture and it won't affect the yield depending on the crop, particularly with a crop like soybeans, it's very hardy. But with plants that you're buying from the nursery, the idea is that it looks perfect when you buy it and doesn't have little nibbles. It's completely pristine. So there's a big premium in having those perfect plants in the nursery industry. So there's a big incentive to use pesticides like neonics, and we know that they're pretty widely used. Again, neonics do dissipate over time, so that plant may be toxic when you buy it, but over time that will dissipate and those levels are much lower than if you had applied it yourself. But as I'm sure this group knows, there's a lot of nurseries that are organic nurseries or they sell native plants. Most native plant nurseries, if they're focused on that, do not use neonics. And you can always ask too. They may not know or they may not tell you, but some nurseries actually advertise that. So I would encourage folks to look for that and to buy from those folks.
Thank you. Noelle, would you like to
Well,
do an
I
outro
just
here?
want to say thank you very much because this was extremely informative. And I do have someone, Lena, that I think I might also be able to refer to you. So I'll get with you afterwards, after the program. But yes, I really appreciate you coming and doing this. And I I certainly support all of your efforts, and I hope that you are successful in convincing the EPA to make some much more restrictive regulations regarding these neonics. But thank you very much. I appreciate it, and thank all of you for coming. This has been a very informative evening. Thank you. Good night.
Thank you all. Thanks for having us.
Thanks so much.